Ever look up at a jumbo jet soaring overhead and wonder, how on earth does that thing stay up there? We're talking about hundreds of tons of metal, hurtling through the air at hundreds of miles per hour. It seems to defy gravity. You might even think, it's a bird, it's a plane. No, it's a giant leap of faith. But fear not, intrepid traveler. There's no magic involved, just good old-fashioned science and engineering. Planes don't stay up because of luck or wishful thinking. They stay up because of some fundamental principles of physics, ingenious design, and rigorous safety protocols. Think of it this way, flying might seem like magic, but it's really just controlled falling. And we've gotten pretty darn good at controlling it. So buckle up, adjust your tray table, and prepare for takeoff as we delve into the fascinating world of aviation safety. Let's start with the basics. Lift. Lift is the force that counteracts gravity and keeps a plane aloft. Think of it as the up force that balances out the down force of gravity. But how does it work? It's all about the shape of those magnificent wings. Airplane wings are cleverly designed with a curved upper surface and a flatter lower surface. This shape, known as an airfoil, is crucial. As the plane moves forward, air flows over both the top and bottom of the wing. The curved upper surface forces the air to travel a longer distance than the air flowing under the wing. This difference in distance creates a difference in air pressure. The air pressure above the wing is lower, and the pressure below the wing is higher, and voila! Lift is born. It's like an invisible hand pushing the plane upwards. The faster the plane moves, the more lift is generated. Pretty neat, huh? Now lift is just one part of the equation. We need another force to get the plane moving forward in the first place. Thrust. That's where those powerful engines come in. They create thrust by sucking in air and blasting it out the back at high speed. Think of it like swimming. You push water backward with your arms and legs, and that propels you forward. Thrust works the same way, only with air instead of water. But wait, there's more. As the plane moves through the air, it encounters resistance. Drag. Drag is the force that opposes thrust. It's like trying to run through a swimming pool. The water creates resistance and slows you down. Engineers spend countless hours designing planes to minimize drag and maximize efficiency. Every curve, every contour is carefully considered to help the plane slip through the air with the least amount of resistance. Speaking of design, modern aircraft are nothing short of engineering marvels. From the earliest Wright Flyer to today's massive Airbus A380s, airplane technology has come a long way. Modern planes are built with advanced materials like lightweight composites and strong alloys, making them incredibly strong yet surprisingly light. Remember that whole hundreds of tons of metal thing? Well, these days a significant portion of an aircraft's structure is made from materials that are stronger than steel but lighter than aluminum. It's like building a skyscraper out of super strong feathers. And let's not forget about the countless hours of computer modeling and wind tunnel testing that go into refining every aspect of an airplane's design. It's all about squeezing every ounce of performance and efficiency out of those magnificent flying machines. Section 5. Redundancy is key. Backup plans for backup plans. But what about safety, I hear you ask? Well, that's where things get really interesting. Aircraft safety is all about redundancy. In other words, having backup systems for backup systems. Think of it like this. Your car has one engine, one alternator, one battery. An airplane, well, it usually has at least two of everything. Two engines, two sets of flight controls, two electrical systems, and often even 3 or 4 hydraulic systems. Why so much redundancy? Because in the unlikely event that one system fails, there's another one ready to take over. It's like having a co-pilot for every single component on the plane. This built-in redundancy is one of the main reasons why flying is statistically safer than driving, cycling, or even walking across a busy street, though I wouldn't recommend walking across a busy street either. Section 6, Maintenance Mania, keeping planes in tip-top shape. And speaking of safety, let's not forget the unsung heroes of aviation. The dedicated mechanics and engineers who keep these complex machines running smoothly. Airplane maintenance is no joke. These highly skilled professionals follow rigorous maintenance schedules that would make your head spin. Every nut, bolt, wire, and hydraulic line is inspected and tested regularly to ensure it's in perfect working order. Planes undergo routine checks before each and every flight, and I'm not talking about a quick once-over with a wrench. I'm talking about comprehensive inspections covering everything from the engines and wings to the avionics and landing gear. It's like giving your car a full checkup before every single drive, And trust me, you'd want your mechanic to be that thorough if you were hurtling through the air at 35,000 feet. Section 7. Pilots, the unsung heroes of the skies. Of course, no discussion of aviation safety would be complete without mentioning the highly trained professionals at the helm, the pilots. These men and women are the unsung heroes of the skies, responsible for the safety and well-being of hundreds of passengers at a time. Pilots undergo years of rigorous training, including countless hours of flight time, simulator sessions, and emergency procedures drills. They're trained to handle just about any situation imaginable, from engine failures and severe weather to medical emergencies and unruly passengers. And if that's not enough, they also have to be experts in navigation, meteorology, aerodynamics, and communication. It's like having a PhD in flying. So next time you're on a flight, take a moment to thank your pilots. They're the ones who make those smooth takeoffs, comfortable flights, and safe landings possible. But pilots aren't alone up there. They have an entire team of highly skilled professionals on the ground supporting them every step of the way, air traffic controllers. These unsung heroes work tirelessly behind the scenes to ensure the safe and efficient flow of air traffic. They use sophisticated radar systems, communication equipment, and a whole lot of brainpower to guide planes safely through the skies, preventing collisions and keeping everything running smoothly. Imagine trying to direct traffic in a busy city, only instead of cars you're dealing with hundreds of airplanes traveling at hundreds of miles per hour. That's the challenge air traffic controllers face every day, and they do it with remarkable skill and precision. So next time you hear that familiar ding as the pilot announces your descent, remember the air traffic controllers who are working hard to get you safely back on the ground. Now, let's talk about everyone's favorite in-flight experience: turbulence. Those unexpected bumps and drops can be a bit unnerving, but rest assured, modern aircraft are designed to handle even the roughest of rides. Turbulence is caused by a variety of atmospheric factors such as jet streams, thunderstorms, and even mountain waves. While it can be uncomfortable, it's important to remember that turbulence is rarely dangerous. Modern aircraft are built to withstand forces far greater than anything you're likely to experience during a typical flight. Think of it like riding a roller coaster. It might be a bit bumpy, but the track is designed to keep you safe and sound. Pilots are also highly trained in handling turbulence. They use a variety of techniques to minimize the bumps and keep the flight as smooth as possible. So sit back, relax, and maybe order another ginger ale. Those clouds will pass soon enough. As impressive as modern aviation is, the future of flight is even more exciting. Engineers and innovators are constantly working on new technologies and advancements that will make air travel even safer, more efficient, and more environmentally friendly. From self-flying planes and electric propulsion systems to advanced materials and predictive maintenance technologies, the possibilities are endless. Imagine a future where planes are powered by renewable energy, flown by sophisticated autopilot systems, and monitored in real time to prevent any potential issues before they even arise. The future of flight is bright, and it's only a matter of time before those futuristic concepts become a reality. So buckle up and get ready for an even smoother, safer, and more amazing flying experience. So, there you have it, a glimpse into the amazing world of aviation safety. From the fundamental principles of aerodynamics to the dedication of countless engineers, mechanics, pilots, and air traffic controllers, a lot goes into ensuring that every flight is as safe as possible. Next time you're soaring through the skies, remember all the science, engineering, and human ingenuity that went into getting you there. So relax, enjoy the ride, and marvel at the incredible feat of human achievement that is air travel. And who knows, maybe someday, you'll even be inspired to join the ranks of those who make the magic of flight possible.